This is the solution video for question 12 from paper 1 of the 2019 TMUA or CTMUA exam. In this question, we're given the following equation that dv by dt, or the differential of v with respect to t, is equal to 24 pi times t minus 1 all over 1 plus root t, and this is for any t greater than or equal to 1. We're then given the additional information that v is equal to 7 when t is equal to 1. And given all this, we're asked to find v when t is 9. And we're given a few different options for this. We're given 6 options here for what v is when t is 9. We have to be a little bit careful with this problem because our first instinct, or at least mine, was to try and integrate both sides with respect to t. That's definitely what we want to do, in the end at least. However, you'll note that this right-hand side is actually quite difficult to respect to t, especially in this form. We don't know a general way to integrate things that look like this. So we need a little trick, and what we notice is we've got a t to the half here, or a root t, and we've got a t to the power 1, or just a standard t up here. So something like difference of two squares, expanding this, might get us somewhere, and indeed it does. So with difference of two squares, we can write this. T minus 1 is equal to root t plus 1 times root t minus 1. So let's shove this information into here and see what happens. So we've got dv by dt is equal to 24 pi times root t plus 1 times root t minus 1 all over 1 plus root t. And you can probably see why this has helped us now, because these two things just both cancel. And so we have dv by dt is 24 pi times root t minus 1. And now we can follow our instinct. We can integrate both sides with respect to t, happily, because we know we can integrate this. So we know v is equal to the integral of 24 pi times t to the half minus 1, where I've just changed the root t to a t to the half to make the integration a bit more followable. And then up the power by 1, so t to the 3 over 2, and divide by 3 over 2, which is the same as times by 2 over 3. And then minus 24 pi t, and then plus our constant. It's crucial we remember this because we've got a condition later. And let's tidy this up a bit for the later stages. So 2 over 3 times 24, 16 pi t to the 3 over 2, minus 24 pi t plus c. So we have our equation now. V is 16 pi t to the 3 over 2, minus 24 pi t plus c. And our next goal should probably be to find c. So how do we do that? Well, to find c, we need a condition. And fortunately, we're given one. We're told when t is 1, v is 7. So let's take this, sub in t is 1, v is 7, and we should be able to calculate what c is. So we know 7 is equal to 16 pi times 1 to the 3 over 2, minus 24 pi times 1 plus c. Now 1 to the 3 over 2, 1 is 1, and we just get minus 24 pi here. So we get 7 equal to minus 8 pi plus c. So bringing all this over to the other side, we get c is 7 plus 8 pi. That's excellent, because now we've got a full expression for v. 16 pi t to the 3 over 2 minus 24 pi t plus 7 plus 8 pi. And this is also quite reassuring to see because we've got the plus 7, which is in all these answers. So we are certainly on the right lines. So now we need to find v when t is 9. So let's substitute in t is 9 and see what happens. So now v at t equals 9 is 16 pi times 9 to the 3 over 2 minus 24 pi times 9 plus 7 plus 8 pi. So we know 9 to the 3 over 2, well we know 9 to the half is 3, so we get 3 cubes, so we get 27. So 27 times 16, lots of pi, minus 24 times 9, lots of pi, plus 8, lots of pi, and then we've got the 7 hanging around here. So we do this by a combination of column addition, column multiplication, or whatever we can do in our heads to calculate this sum. And it will be 224 in this bracket, so we get 7 plus 224 pi is a value of v when t is 9. So now let's look at our possible answers, and we see that this matches perfectly with c. And so we know our answer is C, and v is 224 pi plus 7 when t is 9.